All right, I actually think multiplying is easier than adding and subtracting. That's just my personal opinion. Once we get through these examples, you should have an opinion of your own. So in example 17, you're going to be seeing problems that look like this. 5 square root of 3 times 4 square root of 3. 5 square root of 3 times 4 square root of 3. If you're multiplying, you don't have to have the same number underneath the square root. This is just an example where you do have the same number under the square root, but you don't have to. When you're multiplying, you only have to have the same number under the square root if you are adding or subtracting. Okay? So if we're multiplying, we multiply the numbers on the outside. So the numbers on the outside are 5 and 4. So you'll multiply the outside numbers together. 5 times 4 is 20. You'll multiply the inside numbers together. So the square root of 3 times the square root of 3 is going to be the square root of 9. So your outside numbers get multiplied together. Your inside numbers get multiplied together. But what you get when you multiply your inside numbers has to go back under the square root. So outside times outside, inside times inside. Put your inside answer back under your square root. Once you do that, then it just becomes a simplifying problem, something that you've already done. Is 9 a perfect square? Yes. What's the square root of 9? 3. So this problem really says 20 times 3. And 20 times 3 is 60. All right. Outside times outside, inside times inside. Simplify. Sample 18. 3 square root of 6 times 4 square root of 18. 3 square root of 6 times 4 square root of 18. So again, if we were adding or subtracting, we could not add or subtract a square root of 6 with a square root of 18, but multiplying is different. Okay? You can multiply two different numbers under your square root. We've got to do outside times outside first. So 3 times 4 is 12. And then we'll do inside times inside. So square root of 6 times square root of 18. I need a little help there. What's 6 times 18? 108. 108. You just got to remember to put 108 back underneath your square root. So anytime you multiply two square roots together, you've got to put that product, that's the answer that you get when you multiply, back under the square root. Everybody understand the 12 square root of 108. All right, now your job is just to simplify. Is 108 a perfect square? Okay? If you don't know, you'll take the square root of it in your calculator and you'll get a decimal. So it's not. So you got that list of perfect squares. What's the largest perfect square number that will go into 108? 36. We saw 108 pop up at least twice on the Cahoots game yesterday, I believe. 36 times what is 108? 36 times 3. Take the square root of 36, which is 6, comes out. There's already a number outside, so those two numbers get multiplied together, and you end up with 72 outside and 3 on the inside. I would rather multiply square roots all day long than add or subtract. It's just easier to me. Outside times outside, inside times inside, simplify that answer just like you've been taught. All right, you may have some fractions. So we're not going to freak out when we see the fractions. We're going to stay calm because fractions are just fractions. All right. So both of these fractions are underneath the square root. So what we're going to really do is I'm just going to write this as one big square root. We've got to multiply these two fractions together and put the answer back under the square root. So this is really what we're doing. You might can do this in your head, or you might not do this step, but for our notes, let's just go ahead and write this down. Okay, got a question for you. Do you have to have a common denominator if you're multiplying fractions? No. When do you have to have a common denominator? When you're adding or subtracting. So I don't have to find a common denominator here, but I do have a shortcut, or you have a shortcut that you learned that might help you as you're multiplying. What could we do here? We could cross multiply. It's not really called cross multiply, it's called cross cancel. So y'all know how you can look at those fives and say, is there anything that will go into 5 that will also go into 5? And the answer is, okay, so 5. So 5 goes into 5 one time. 5 goes into this 5 one time. Then you can look crossways at your 3 and 12. Is there anything that will go into 3 or 12? 3. So 3 goes into 3 one times, and 3 goes into 12 4 times. That's just called cross canceling. That just helps us not have a really big fraction that we have to reduce in the end. So then we do top times the top. So 1 times 1 is 1. 1 times 4 is 4. So those two fractions multiply to be 1/4, but that number is still under the square root. Okay, let's say you didn't cross cancel. So just think about this. You would just do 3 times 5 is 15. Let me just show you. If you don't cross cancel, 5 times 12 is 60. Then 15 and 60 reduce by 15. And you would just have to do the work to get that reduced. And that would also give you 1/4. So what the cross canceling does is it helps you not have a really big fraction at the end that you have to reduce. You can do it either way you want. You can actually take your calculator and do 3 ABC 5 times 5 ABC 12, and guess what it'll give you? The simplified fraction of 1/4. So maybe you just want to use your calculator on that one. All right, we're not finished yet. We've got to take the square root of 1/4. So we take the square root of the top. The square root of 1 is 1. And we take the square root of the bottom. The square root of 4 is 2. So 1/2 times itself 2 times is 1/4. So your final answer is 1/2. So we actually could have made that problem shorter. Let's just talk about if we used our calculator here. So if we used our calculator, we would just multiply 3/5 times 5/12. That would just give us straight up 1/4. Because the calculator knows how to reduce fractions after you multiply. And then we take the square root of the 1, which is 1, and the square root of 4, which is 2. Now I just want to do that one in your calculator. What do y'all think? So glad y'all are talking to me this morning. All right, we gotta have some problems that have some variables in them. So example 20's got to have some variables in them. You got 4c to the third, square root of 4c to the third, d to the third, times square root of 8c squared d. So as long as we're multiplying, we don't have to have the same thing underneath. We're just going to multiply everything under one square root times everything that's under the other square root. So we're going to do 4 times 8, which is going to give us what? 4 times 8 is 32. C to the third times C to the second is C to the fifth, because remember when you multiply variables you add their exponents, and d to the third plus d to the 1 is d to the fourth. So you're just going to multiply what's underneath the square root, and then you're going to simplify it. Is 32 a perfect square? No, there are two things that will go into 32 that are perfect squares, but what's the largest number? Okay, 4 will go into 32, but so will 16. So you need to use the largest one. So that's 16 times 2. Is c to the fifth a perfect square? No, because 5 is not divisible by 2. So remember what we do here is we take 1 away from the 5, and that gives us a 4. So we have to do c to the fourth times c. d to the fourth is a perfect square because 4 is divisible by 2, so you just bring down your d to the fourth. Then 3 things are perfect squares. What are they? 16, c to the fourth, and d to the fourth. So square root of 16 is 4. What times itself 2 times is c to the fourth? C squared. Good. So bring out c squared. What times itself 2 times is d to the fourth? D squared. That's what's going to be outside. On the inside, you're going to be left with just a 2 and a c. Whatever you didn't mark out, that's what's left under the square root. That's why it's a good idea to mark out what you're going to take the square root of so you can see what's left. All right. Last example coming up, 21. I'll squeeze 21 in right here. All right, we've got 5 square root of 15, parentheses, bless you, 2 square root of 3 plus 4 square root of 5. Last example for multiplying. 5 square root of 15 times parentheses 2 square root of 3 plus 4 square root of 5. This looks like something that starts with a D that you've done before. You may know. Starts with a D. The distributive property. You got something on the outside of a parentheses, and that something needs to be distributed or multiplied into your parentheses. So we've got to multiply these first two numbers together. So outside times outside, inside times inside gives me what? Outside times outside, inside times inside gives me 10 square root of 45. 5 square root of 15 times 2 square root of 3 is 10 square root of 45. Then you've got to multiply 5 square root of 15 times positive 4 square root of 5. So outside times outside and inside times inside gives me positive what? 20 square root of, what's 15 times 5? 75. Y'all with me? So everybody see how we're getting 10 square root of 45 plus 20 square root of 75? Alright, these will be the hardest ones. Alright, is this the answer? No, why is this not the answer? Got two square roots that can be simplified. 45 can be simplified because what goes into 45? 9. 9 times what? 9 times 5. 75 can be simplified under the square root because what goes into 75? 25 times what is 75? 3. Alright, you're never finished if you have a number under the square root that still has a factor that is a perfect square. So we're going to take the square root of 9, which is 3. 3 comes out. There's already a number outside. Those numbers get multiplied together. So that gives me 30 square root of 5. The square root of 25 is 5. 5 comes out. There's already a number on the outside. Those numbers get multiplied together. 5 times 20 is 100. And 3 is left underneath the square root. Okay, so we have simplified the radicals. The next question is, can you add 30 square root of 5 with 100 square root of 3? No, you cannot add or subtract unless you have like terms. And the square root of 5 and the square root of 3 are not like terms.